Welcome to Faith and Science. I'm Dr. John Ashton. Just recently I was at a wedding and happened to sit next to a guest, and we got talking, and I found out that he went to Newcastle Uni and started the same year I did back in 1964, and we compared notes and were checking who we remembered being in our classes and so forth. It was really great to catch up. And that followed on. It turned out that later on this person had become the principal of the high school that I had attended many years before. And that again reminded me of, and we again compared names, what the original principal was, because the school that I went to, I was in the first intake at that. It was of that brand new high school. And I remember the first science master there, and I topped science in the A class, and I remember the teacher didn't have a special prize, but he gave me a book, one of the science books that he'd picked up at a conference from that had been written by a famous Australian physicist, and he gave that to me as a prize, and that was very encouraging. And as I recall and thought about this, I remember learning about the theory of the origin of the solar system, and the origin of the solar system that we were taught back then was that there was originally this orbiting cloud of dust was orbiting, and gradually this cloud condensed, and they formed the Earth, and the different planets formed as this big rotating cloud of dust condensed. And of course this is known as the condensation theory. And I found out fairly recently, of course, that it was actually proposed, back, many years earlier, of course, as a possible explanation for how the moon formed. So you had the moon formed as this condensing cloud of dust as gravity pulled the tiny particles together. Well, of course, we know actually that doesn't work really well, but there are major problems with a number of theories with the Earth. Another theory was that originally the Earth was this molten blob that spun really fast, and it flew off a smaller blob. As it ran around, a little blob flew off. And this is known as the fission theory. And of course, it was interesting to read that this was actually proposed by George Darwin, the son of Charles Darwin. But it's interesting when we look at these theories that they actually don't fit the science. For example, calculations that have been done show that the Earth's rotational speed would never have been great enough to actually fling off a small particle that would have formed the moon. Another problem is the marked differences between the rocks that are found on the moon and those on the Earth. So again, with the condensation theory, we would expect the moon to be like a mini Earth that is made up of essentially the same minerals and have a similar composition of the Earth. So if as I said, this theory that I was taught back in school in it would have been the late 1950s, 1959, 1960, around that time, the composition, if it was this dust cloud, then we would have expected all these planets to have roughly the same composition. But we know they're vastly different. And of course, the moon is significantly less dense than the Earth. And we know that it's made up of quite different materials. And it seems, and we don't know for sure, scientists don't know for sure, but this explanation of the vast difference in density is attributed by scientists to the fact that it's evidence that the Earth has this very heavy core, possibly an iron silicon type core, whereas the Moon must have a much smaller iron type mineral core. If we go then to the fission theory, as I said, we would have expected that the composition of the Earth, of the Moon rather, would be very similar. But when we look at the elements, for example, potassium and sodium are found in abundance in the Earth's rocks, but not very much in the rocks on the Moon. Conversely, the Moon rocks contain significantly more aluminium, calcium and thorium. So this is, a major problem for the fission theory, and it's also a problem for the condensation theory. Another good reason for rejecting this fission theory, or the split off, that this blob thing, is the Moon's orbital path. We would expect the Moon to orbit, if this theory is correct, we'd expect the Moon to just simply orbit around the Earth's equator, but it doesn't. So it's fascinating that when we look at these, different theories to try and explain the origin of the Earth, these are the common ones that were taught to the people that went on to become, the science teachers and university professors and so forth, that they actually don't fit the data. Then, of course, there's another one, that the Moon came from outer space. And, of course, this is what a number of scientists call on at different times. So I remember seeing an interview with Richard Dawkins, the really strongly outspoken proponent of evolution, and when he was pressed for saying, how did life originally form? Because we know from the science, from the chemistry underpinning life processes, that it's absolutely impossible for a living cell to arise from non-living chemicals. For example, recently I watched a talk by James Tour, Dr. James Tour, who's a professor at Rice University, a world-leading scientist that builds molecular machines. And one of the things that he was pointing out on his talk was that with the best scientific technology and equipment, our best skills and knowledge, we still can't assemble the molecules to form the envelope of a simple cell. And that envelope is essential to protect and preserve the biochemical process and biochemistry that would go on inside a living organism. So what he's saying is that the way these molecules have to be assembled, even with our best skills today, we couldn't assemble them. And so we have this overwhelming evidence that life can just not form by itself. And so, again, when Richard Dawkins was pressed about this point by the interviewer, he said, well, maybe it came from outer space. Well, it doesn't really change things because we work on the assumption that the chemistry in outer space operates the same as the chemistry we would observe here on Earth. But again, they've tried this explanation for the origin of the Moon. And some have argued that the Moon must have formed elsewhere, and as it flew through the galaxy, it just happened to pass close enough to the Earth to be captured by Earth's gravity. But again, if this were the case, we would expect the Moon to follow a elongated orbit, a sort of an elliptical sort of orbit, or a very elongated orbit, more like that of Halley's Comet around the Sun. But the Moon's orbit is essentially circular. So again, this theory fails. Now, at the present time, probably the most popular theory for the origin of the Moon, is that there was some great impact. And this is the most popular theory among evolutionists today. And so it holds that there was a hypothetical planet, they even give it a name, Theia, that collided with the Earth, and the resulting debris formed the moon. And this is said to explain the difference, for example, between the Earth's rocks and the moon rocks that I mentioned just a moment ago. And essentially what they argued that the high temperatures that would have been generated by the impact, all this kinetic energy, part of it would have been converted into heat energy, would have boiled away the volatile elements such as potassium and sodium. That's what they say off the moon, and left the more heat-resistant minerals like the aluminium, calcium and thorium. So that's their explanation to explain the different mineral composition. But, and that leads to problems, that what about the similarities between the rocks? And this is a major problem, looking then at, okay, there are a lot of similar rocks between the moon and the Earth. And with the impact theory, part of the moon would have formed from the Earth and part from the remaining impacting planet. So the chemistry of the moon rocks would be expected to be quite different from that for the Earth rocks. And while it's true that the moon is deficient in some Earth elements, there are also shared elements that have very similar properties. Now, elements can come in different forms that we call isotopes. For example, we know that we often talk about carbon-14 dating. Well, carbon-14 is an isotope of carbon that has an atomic weight of 14 because it has the extra neutrons in the nucleus, whereas the most common form of carbon is the isotope carbon-12, which has just 6 neutrons in the nucleus. So the isotope is an element that has a different weight. So elements are defined by the number of protons in the nucleus, but they can have different numbers of neutrons, which gives them different atomic weight. And so these are the different isotopes. And one of the fascinating signatures is that the isotope ratios of elements like oxygen, iron, hydrogen, silica, magnesium, titanium, potassium, tungsten, chromium are almost identical on the moon to Earth rocks. At the same time, they're very different from the ratios we observe from spectra on other solar system bodies. And this is a real major problem for the impact theory. And so essentially the impact theory is in crisis. And this was this research came out a few years ago now. Some of the original research, or the summary, was published in National Geoscience, Volume 6, in 2013, pages 996 to 998. And the title for the article, if anyone wants to Google it, is Occam's Origin of the Moon. So it's in Nat Geoscience, Volume 6, 2013, Occam's Origin of the Moon. The author was Elkins Tanton, and he looks at a lot of this data in detail. Another paper, and it's interesting, that evolutionists have got major problem with the trying to understand the origin of the moon. Matter of fact, another paper that was published just 2 years ago, 2017, in Nat Geoscience, was the title of that paper was A Multiple Impact Origin for the Moon. So a multiple impact origin for the moon. And that was by a leading planetary scientist, Professor Oded Ronson. And it's interesting, he starts the paper with the moon's origin remains enigmatic. In other words, it's a major problem. And one of the major problems is, of course, the angular momentum of the moon. Now, angular momentum is the momentum as a result of an object spinning. So if we all know that if you're driving along on your car and you sort of push the clutch in on the car, say as you're coming up to a traffic light ready to change gear, the car keeps going, even though you've got your foot off the accelerator and you're wanting to slow down. You put your foot on the clutch, the car will still roll, and that's due to its momentum. In other words, it's the energy that's continues to carry it along, and that's one of the laws, that every object continues unless it's acted upon by an external force, and we apply the external force of a brake to slow it down, or else there's air resistance or tyre resistance, which are forces. And it's the same as something rotates as well. And I know this is one of the things I enjoy with my children. There's a little mini merry-go-round, and I explain to my children that if you hop on this thing and you spin it really fast while you're standing close to the centre pole, and then as you move out, it slows down, and then as you come into the centre, it speeds up again. And so this is, of course, the angular momentum. And one of the things that we observe is, and of course, the faster an object moves, the greater or faster it rotates, the greater angular momentum that it has. And of course, we can calculate the angular momentum of the Earth together with its moon. And one of the things is that any explanation for the origin has to explain these origins, because, and this is where the condensation theory fails, because when we compare other planets in our solar system and their moons, the Earth-Moon system has too much angular momentum. We've got a lot more angular momentum. Similarly, the fission theory, where a blob spun off the Earth, fails because it has too little angular momentum. And so the Earth doesn't have enough angular momentum for the Earth to be finished spinning that fast. The impact theory also fails because the impact scenarios, which attempt to, explain the origin of the moon by impact, again, would result in too much angular momentum, more angular momentum that we measure. So, and that was, came out in that paper that was published in Nat Geoscience 2017. And so, again, it's fascinating that when we look at the evidence out there, there's powerful evidence that the moon was created, special, to provide this purpose, and at just the right size too, and just the right position for us to observe lunar eclipses. It was interesting. I was reading an article about a new book that has come out by a Christian satellite engineer, Dr. Henry Reicher, Reichter, and he was actually the development manager of Explorer 1, America's first satellite that was put up in the 1950s. And he's actually put out a book called Spacecraft Earth, a guide for passengers. And this book, as I said, the title of his book is Spacecraft Earth, a guide for passengers. And his name is Dr. Henry Reichter, Reichter. And it's a Christian book. It's overtly Christian. And in it, he talks about the evidence for intelligent design in our solar system and in our universe. And he worked at the JPL, the Jet Propulsion Laboratory in the United States, one of the top research laboratories in terms of space exploration and this sort of thing. And one of the things that he points out is that the research that they did early on, they discovered the very high energy radiation belts these ultra-high energy electron-type particles that are coming, and of course the role of the Earth's magnetic field to protect us from these really dangerous high-energy particles in the solar wind that stream out of the sun. And so the important role of the strength of the Earth's magnetic field. And then, of course, talking about the Earth now in his book, he talks about how the atmosphere of the Earth protects us from the cosmic rays, and the Earth's magnetic field, of course, protects us from cosmic rays. And then the atmosphere also shields us from helps burn up the small meteorites and these sort of things that are coming into to Earth. And it points out too that there are cycles in the elements. I wasn't actually aware of this, but the Earth cycles many necessary elements. Well, I knew about carbon and nitrogen, but I didn't realise that iron and oxygen, even bromine, were cycled. And without this, there would be no animals. And that was some interesting work on that that he reports in his book. He talks about the evidence for a young Earth and correspondingly a young moon as well. One of the important areas of that is the work on the decaying Earth's magnetic field. A lot of work was done by Professor Thomas Barnes, who's Emeritus Professor of Physics at the University of Texas, El Paso. And he did a lot of work showing that the implications of the Earth's magnetic field are very important in preserving life. And, of course, the evidence from its decay rate, again, shows that the Earth cannot be very old. The other thing that Dr. Richer points out is, of course, the habitable zone for stars. So he's done a lot of work on the star area and how the habitable zone for a planet around a star is it's very critical. One of the important things is that the planet must not be locked into a star by tidal forces, because when this happens, what it means is that the planet would always face the star the same way. So you're going to have, huge temperatures on one side, very hot one side, and very cold the other side. So that greatly reduces the area that life could provide on. The other factor is the planet must have a nearly circular orbit around the star so that the temperature range stays just in the range that allows liquid water to be there. And again, this is one of a dozen or so factors that Dr. Reicher points out in his book that are essential for life to exist, and how unique our Earth-Moon system is. And we know from observations that very, very few planets could actually meet this system. Most of the planetary systems discovered by the Kepler spacecraft look nothing like our solar system. Many of them have really large hot Jupiters, or they're giant gas planets orbiting close to the star, or they have planets in highly eccentric orbits. And it's interesting too, one of the things in his book that he points out is that most stars don't actually permit habitable zones, because the hot blue stars give off far too much ionising radiation, and the cool red dwarf stars, which are the most numerous, it would seem, in the universe, they tend to tidally lock their planets. And also these red-type stars produce deadly superflares that would tend to fry from time to time planets in the habitable zone. So it points out our sun is actually one of the quietest stars that we observe. Only 0.06% variation in energy reaching the Earth over a measurement period of about 32 years where they studied, and that was some, it's very interesting studies that they're doing there. So we have so much evidence that the moon and the Earth have been, created. Another book has also been published. It's called, and this is by a cosmologist from the University of Sydney. It's called A Fortunate Universe, Life in a Finely Tuned Cosmos. And that's been published recently, 2016, by Cambridge University Press. And that's Durant Lewis there. So again, we're finding more and more evidence for a really specially created universe and planetary system. Our Earth seems to be in just the right spot to observe the universe. We're in a special part where we seem to be in a position to observe most of the universe. And this I find is really, really exciting because quite clearly God revealed that he created the universe. He stretched the heavens out. And the Bible talks about this very clearly. Well, I get really excited about this information and about the fact that science is confirming so much that the universe is so special in the way it is, and particularly our planet, that we must have been created. It just couldn't arise by chance. And as science recognises this, I'm just so passionate. This needs to get out to people, that we have this evidence that we were created and by a loving God. And that's what the Bible tells us too. And remember, by going on to the internet and Googling 3abnaustralia.org.au and click on the listen button, you can listen to these programs and get the references and check them out for yourselves. I'm Dr. John Ashton. Have a great day.
You've been listening to a production of 3ABN Australia Radio.